Let's look at another exponential equation here. Again, under the constraints that Math Excel has given us, solve the exponential equation, express the solution in terms of logarithms now. It doesn't say natural log, so I'm assuming we can use whatever logarithm we want. When you have an exponential variable like so, and I'm just going to write them like this, nice and big so we can see them. What I've said in some previous videos is when you're going to use a logarithm, well, first of all, you can't express 5 and 6 as powers with the same base. Okay, that would get super messy. So we're going to have to use logarithms to be able to get at these variables up here, right? We want to bring them down. To do that, you need to take the log of both sides. Now, in a situation where both of these exponential terms have variables in them, you can kind of take your choice. Now, if this wasn't up here and the variable was only included here, I would definitely do log base 5, okay, for reasons that have been discussed in a previous video. But if I did log base 5, just to rehash this idea, if I did this, when the 2x plus 1 comes down, the log base 5 of 5 completely goes away, right? Because that's equal to 1, right? It's not equal to 0, it's equal to 1. In this case, I would have to also do log base 5 over here, and log base 5 of 6, totally different value, right? So normally what we would say is choose a base for the logarithm that matches the base of the variable exponent. Now, since there are 2 variable exponents, we get to pick. It's not going to make a huge difference in this case which one we do. For the sake of, continuing down the path that I just erased, which I probably did a little too early, this exponent looks a little worse than this, right? Because of the 2 here. So whichever one of these exponents is more intimidating, should we say, let's get rid of the base of that exponent. So I am actually going to do log base 5. I could do common log, okay? I'm choosing log base 5, but I could do the common log. That's not going to ruin things. But choosing log base 5, and then that 2x plus 1 comes down in front, okay? Like we said, what happens here? The x minus 1 comes down over here. We've got log base 5 of 6. So what happens to the log base 5 of 5, right? Log base 5 of 5 has a value of 1, and 1 times 2x plus 1, well, that's just 2x plus 1. And that's equal to x minus 1 times log base 5 of 6. Now, something to keep in mind. This logarithm is a number, okay? And if I'm solving for x, okay, what we have to do to get this x term all by itself, all right, is a little bit of work here, right? So we're going to have to, you have 2 choices. If you want to get the x terms together, you can do that, but we may have to distribute this into this quantity. So now we have 2x plus 1 equals x times the log base 5 of 6 minus the log base 5 of 6, right? So we have an x term. This is a really horrible looking x term, right? And we have a non-variable term. This is, again, remember, this is equal to a number. Now, if we had an equation that said, 2x plus 1 equals x minus 1 times 3, I would want to distribute this 3 and then get the x terms together, right? So just go through it like so. I'd have 3x minus 3. I'd want to move this x over. So I'd subtract 3x from both sides, so on and so forth, right? You would know how to do this if you're in this course. Now here, I still want to get the x terms together, and I still want to get the constant terms together. So I'm going to subtract this from both sides. Minus x log base 5 of 6 minus x log base 5 of 6. Now, the way that I'm writing this, okay, gets a little funky because in this case, I'm actually putting the coefficient or the numerical part of this behind the variable, okay? Really, it should be log base 5 of 6 in front of the x because I put the 2 in front of the x, right? Now, this is 2x minus x log base 5 of 6 plus 1 equals negative log base 5 of 6. Okay? Don't focus on the log base 5 of 6's being the same. Focus on getting these x's together. All right? So now I'm going to move this constant to the other side so that my x terms are together. So I'm subtracting 1 from both sides. So now I have negative 1 minus log base 5 of 6. Oh, where's my screen? Sorry. Here we go. Now, how do I solve for x? Factor the x away from this expression. 2 minus log base 5 of 6. The x is on the outside. How do I solve for x? Divide by the number that's being multiplied by it. It's horrible looking. We get that, okay? But here's our solution in terms of x. X is equal to negative 1 minus log base 5 of 6 over 2 minus log base 5. 2 minus log base 5 of 6. Horrible looking answer, okay? It would have been way easier if from the beginning I would have just got a number for this and a number for this, right? Then I could have actually combined these together. But to solve for a variable in this case, I divide that out, okay? Factor that out and then divide by this number. Again, this is written like so, but it represents a number, okay? So I'm just dividing by the thing that's being multiplied by x on both sides.